This is lesson 99A, Intro to Scatter Plots. The objective of this lesson is learn to create and interpret scatter plots. So what is a scatter plot? A scatter plot is a graph with points plotted to show a relationship between two sets of data. Now with these two sets of data, there's going to be a correlation. A correlation describes the type of relationship between the two sets of data. So do you notice a trend? Scatter plots provide a convenient way to determine whether a correlation exists between the two variables. So when you're looking at it, do you notice something that's happening with these dots? That's what you're looking at. Is there a correlation between those? So when we're looking at this, see here we have a positive correlation. You can have either a strong correlation where the dots are really close together and it's nice and tight and going up, or you might have a weak correlation where the line's a little bit looser and the dots are kind of a little more spread out, but they still are going up. A positive correlation occurs when both variables are increasing. So then a negative correlation is going to occur when one variable increases and the other variable decreases. And again, you can have a weak or a strong correlation. Notice though, you've got that negative slope kind of going down. Same with the weak and the strong. Both of them, as you go over, they're going down. But sometimes you might get something and there is no correlation at all. Now, if the data points are randomly scattered, there is little or no correlation. So let's look at a couple. Where we're looking at these, you got A, B, and C here. Which one do you think is the positive correlation? C is going to be your positive correlation. Which one's going to be your negative correlation? B is going to be your negative correlation. And if you look at A here, you notice there's pretty much no correlation at all. The points are just kind of scattered around. No real distinct line. So what would be some things? Let's look at the scatter plots of data related to characteristics of children from 0 to 18 years old. We're going to match each scatter plot with the appropriate variables studied. How would age and height compare? If you think about it, as you get older, so the number increases, your height generally increases. So if you have both of them are increasing, remember, that's a positive correlation. So that would be this middle graph right here. It shows a positive correlation. How about age and eye color? Does it really matter how old you are as far as what color eyes you have? No, it doesn't. So the one that shows no correlation, this one over here on the left, is going to be the correlation between age and eye color, because there really isn't a correlation. So then the third one, age and time needed to run a certain distance. I'm going to guess that for most of you, as you got older, so your age increased, the time it took you to, say, run the mile decreased. So that would show a negative correlation, which is this last one. So do the data sets have a positive, a negative, or no correlation? Think about it. Distance covered and time spent at constant speed. Go ahead, pause the video, and take a guess as to what you think it's going to be. So that's going to be a positive correlation. As your distance covered is going to increase as time increases. So look at number 4 now. If you had the value of a used car and the total distance traveled. So the value of a used car and the total distance traveled. Go ahead and pause the video and find out what you think. I would say that it would have a negative correlation because of the value of the car would decrease. It wouldn't decrease a ton, but it would decrease some. So it would be kind of a weak negative correlation, but as you drive, the more miles a car has, the less it's worth. So let's look at number 5. Now we're given the data, and now we have to make our own scatter plot to determine what kind of correlation this has. Now just remember, all you're doing is plotting points. You're looking at height. Height, you notice, is down here. It's like your X. And the weight is over here like it's your Y. So you're just looking at these as points, like 71, 170. So you come over here to 71 and go up to 170 and put a point. Then you're looking at 68 and 160. 68, 160, it's about right there. 70, go over to 70, up 175, which is about halfway between. 73 and 180. And 74 and 190. What kind of correlation does this look like? So it'd be a positive correlation. So go ahead, pause the video, and try to do number 6 on your own. So if you plotted your points, you should have gotten a graph that looked pretty similar to this. Even though there's one that's kind of out on its own over here, not quite going with the others, we call that an outlier. For the most part, we're looking at a positive correlation. So you go ahead, do number 7 on your own, and bring it up for me to check.